Dear students, actually my aim here is to tell you about image formation in spherical mirrors. Before that, I will tell you something, different things. But you know, parallel ray pass through focus. Parallel ray pass through focus. Now what happens if any ray fall at any other end, at any other point, suppose like this. The ray is incident here. So how to find reflected ray? It is a question here, and I found that student is disturbed by this line. So now law of reflection are to be followed. So here angle, you have to first of all find out angle of incidence. So you join the center to this point of incidence. So this is angle I. So you draw the ray making same angle with this. So it may go like this. I equal to R has been followed. It is not necessary that कि भाई ये क्योंकि ऐसा क्वेश्चन पेपर में पूछ लेते हैं. If it is convex mirror, and suppose ray has fallen like this, so it is center here. It is normal. So this ray will be reflected, making angle reflection like this. So it should be very clear that we have to follow law of reflection. Now, if any other ray, there are different rays, say concave, convex mirror, concave mirror is this, and ray here, pole F and C. A ray falls through C. So you increase the mirror here. I told you that radius perpendicular tangent. So this ray is falling normally. So it will be reflected back on the same path. Similarly here, if in convex mirror, it is C here, it is F here. Now ray has fallen like this. So it is actually being produced here. It will pass through center. So it will be reflected back because it is falling normally. Perpendicular by whatsoever be the path. It is like this. So it is falling normally, come back. किसी भी डायरेक्शन से अगर थ्रू सी जा रही है रे, तो they are reflected back on the same path. Now another point here. If pass through focus, ray after traveling through focus, so suppose it falls like this, so it become parallel, क्योंकि angle of incidence यहाँ होगा, और I equal to R, so that become parallel. Similarly, in case of convex mirror, in convex mirror, this is C and this is F, and ray appear to come and fall at focus. So it is the angle of incidence, so it becomes parallel to principal axis after reflection. Now one more thing which I usually use for making the thing simple. If ray of light is incident at pole, so this is the normal. This is angle I, so it is reflected in this way. And usually I use this ray in explaining things. But remember that angle of incidence should be angle of reflection. Then you have to use your D. So now if it is convex mirror, the same thing. C or A. If it falls normally here at P, sorry, it falls on pole mirror, so reflected back, I equal to R. But remember, you have to keep I equal to R. So you can choose any of these rays while making images in spherical mirror. So first of all, I take image formation in concave mirror. Concave mirror. Remember the image formed by after reflection, where the ray meet really, they form real image. If they appear to meet on producing back, then there will be virtual image. And generally, the real images are inverted. So I am telling so that you can write inverted images. हिंदी में कहते हैं उल्टे इमेज, हमेशा रियल होते हैं. तो नाउ फर्स्ट ऑफ ऑल आई कम हियर व्हेन ऑब्जेक्ट एट इंफिनिटी. Object at infinity. You draw the diagram yourself using pencil and scale. Exactly. This is here center of curvature. Oh sorry, concave mirror. This is pole. This is focus. Exactly at same distance. These distances will be equal. And write first F and C. Write it. Now infinite infinity. Parallel rays meet at infinity. We say like this. We define parallel rays. So if object at infinity, so you can imagine that rays are coming like this, parallel to principal axis, and they converge at focus. So we say highly diminished real image at focus. Highly diminished. Diminished छोटा, small. Diminished. Real inverted image at F. But people say, sir, it is a point image. How do you say it is inverted? So for that, and we need that diagram also. It is concave mirror. One thing here, remember, dear friends, I could not tell because of some reason here. It is F, it is C. If rays are going parallel to each other but not parallel to principal axis, they fall like this. Then rays parallel to each other will have to converge at a point which will be lying in focal plane. यहाँ फोकस है नहीं, तो ये एंगल जो है जितना है इसलिए मैं करता हूँ इतना बनाइए, और यहाँ पर ये बड़ा हो जाएगा थोड़ा, और यहाँ नहीं बना एक्चुअली, यहाँ से इसको मिला दीजिए. So this way you can say that when object at infinity, so image will be at focus, inverted, highly diminished. You can use this diagram while learning about telescopes. So when object at infinity, image at focus. Number 2, object beyond C. Object beyond C. Bachcho, though you are student of class 12, but don't mean that we are grown up well, we can do anything. No. Keep on learning and always listen carefully what others say. Don't have argument in your own brain that I know this thing. And people who think like that can't learn anything. Beyond C means between infinity and C. Concave mirror, इसको तो आप हाथ से बनाएं, लेकिन यहाँ नापन है, पोल्स है, मान लो 10 सेंटीमीटर 820 है, नाप कर लिखें. It is C, it is F, है भाई. So it is object here. So one through C, मैंने रे चूज किया है जानबूझ करके. Another at pole. So it will pass again reflection. So here will be the meeting the rays at between C and F. If you take parallel they also, then it will pass through focus and meet the point here. But I don't take this while doing something. So highly, you can use only 2 rays for your convenience. So object is beyond C, so image real diminished inverted image between F and C. focus और center को किस बनेगा. Now object at C. Object at C. So it is concave mirror. It is pole, it is C, F, it is C. Object itself at C. So image will be at C. In this diagram we feel some difficulty because if we choose rays, actually we are unable to exactly make angle of incidence equal to angle of reflection. So it will be at C, same size. तो पहला आप इसको ऐसा बना लीजिए. Then through focus become parallel, and then mark here the focus here. So real inverted image of same size. Real inverted image of same size at C. If object at C, image will be at C. Don't forget putting these arrows. Arrow must हैं, नहीं तो आपका एक नंबर डायग्राम है, आधा नंबर साफ. 50% marks you have lost. Now object between C and F. Object between C and F. Pole, focus, C. ये डिस्टेंस बराबर होनी चाहिए. Object is here. तो get habit of taking the ray through C. It will be written back because you don't need to make angle incidence equal to reflection. So this will go this way after reflection. Other ray at pole, you can take parallel through focus also, but make habit of this also. It will make same angle and highly magnified real image beyond C. Highly, or you can say or simply magnified means बड़ा. Magnified real inverted image will be highly inverted image will be beyond C. Beyond C, highly inverted, है ना? Now object at F. I am taking different rays in different cases because this diagram is very helpful. This diagram, when we take ray parallel to, we take ray falling on pole. It helps you in making something easy. Now object at F. concave mirror. हाथ चलाइए बार बार प्रैक्टिस कीजिए डायग्राम बनाने का. Then pole F C. Here the object. Again this ray through C reflected back at pole. This angle, sorry, it will go back. They become parallel in fact. A parallel meet at infinity. At infinity. You can say this side also. Here, but generally we say a highly inverted real image at infinity. Now, up to this point, every image is real, inverted. Please try to learn these diagrams and position of object and image because while doing numerical problem, you can decide your answer yourself without doing calculation. Now object between pole and focus. We will say like this के object within focus ऐसे बोलते हैं, object within focus. अगर आपका ऑब्जेक्ट विदिन फोकस है तो क्या होगा? ये कॉनकेव मिरर, ये पोल, ये एफ, ये सी, हियर द ऑब्जेक्ट. One ray through C, reflected back. Another through pole, it go back like this. So this side they are going away from each other. See the ऐसे. If we produce them back, they appear to meet at this point here. Dotted line खींचनी पड़ेगी यहाँ पर आपको. Virtual image is shown by dotted lines. Remember it. तो क्या करेंगे? magnified, erect and virtual image. Behind them. Dear students, dear children, I have learned from books also, but while thinking and meditating myself, I got something different way to tell the students so that things become easier. Now these all are the image formation in concave mirror. Then what happens to convex mirror? How to, and that makes, this is a trouble for student, convex mirror. Image formation in convex mirror. I have told you that real image can be taken on screen, means we can locate the position of, but virtual image cannot be located. Convex mirror, only there are two things about this, C or F. If object at infinity, rays are coming parallel and parallel they will active diverge from focus. So highly diminished virtual image will be at focus. You can write here why highly diminished virtual image. Erect, सीधा. अब आप बोलेंगे यहाँ पॉइंट ऑब्जेक्ट है, तो वी कैन डू दैट आल्सो. हमें कैसे करेंगे उसको? If rays are not parallel to principal axis. तो एक रे हमने ये लिया, reflected back like this. Another we take, sorry, it is F, it is C. Suppose we take through C, ये रे through C है, तो ये reflect होगी back. If I produce it backward, it appears at this point. Again, image will be at C. Erect image बनेगा. You can draw this diagram. This diagram is not drawn in any book. Please listen me carefully. अभी तो आपको है C और F इधर है, लेकिन जब बाद में बहुत दिन बाद पूछते हैं एक कॉन्वेक्स मिरर, मास सेंटर कर्वेचर फोकस, तो सब इधर लिखते हैं C और F. यहाँ F है, यहाँ C. किस F इक्वल टू R/2 रियल. तो भूल जाते हैं इसका इधर सर साइकिल यहाँ भूल जाते हैं हम लोग. In one school I went for exam conduction and no one was able to mark the center of curvature and focus of this side. They all mark this side. क्योंकि convex mirror में दो ही डायग्राम बनते हैं, तो प्रैक्टिस नहीं होती. अब ऑब्जेक्ट convex mirror में कहाँ हो? Convex mirror अगेन. ऑब्जेक्ट एनीवेयर एल्स। एक तो बच्चे पूछते हैं ऑब्जेक्ट कहाँ रखें, जब कहते हैं ना ड्रा कॉन्वेक्स मिरर अगर बना दिया कि शो मी द इमेज फॉर्मेशन, तो बच्चा पूछता है सर वो कहाँ रखें हम ऑब्जेक्ट, क्योंकि उनको आदत पड़ गई ना सी और एफ के बीच में रखें या एट सी रखें या बियॉन्ड सी, तो उसी के तहत बोलते हैं। लेकिन यहाँ कौन नजर क्या है, क्योंकि इसके तो फोकस और सेंटर पर किधर है, दिस साइड, ऑब्जेक्ट तो होगा दिस साइड, तो यू कांट से ऑब्जेक्ट एट सी और एफ। एक कोई भी इक्वेशन बन सकती है कहीं भी सिचुएशन। तो मैं पैरेलल इस रे पर बहुत ज़्यादा ध्यान देता हूँ, और दूसरी थ्रू सी, ये रिफ्लेक्ट बैक ऑन द सेम पाथ, तो रिजल्ट तो मिलेंगे नहीं है। इफ आई प्रोड्यूस इट बैक हियर विल द वर्चुअल डिमिनिशिंग। प्लीज लर्न दिस डायग्राम केयरफुली, दिस इज इंपॉर्टेंट डायग्राम। इसको ही पूछते हैं लोग बाग, और बनता नहीं बच्चों से। अभी मैंने बच्चों को दिया था, मेरे पास आते हैं बच्चे यहाँ, तो दे कुड नॉट, सबने एक बहुत होशियार लड़की यही मार पाया था। तो दिस इज हाईली डिमिनिश्ड वर्चुअल इमेज बिटवीन पोल एंड फोकस। हमेशा कॉन्वेक्स में इमेज बिटवीन पोल एंड फोकस ही होगा, नॉट एनीवेयर एल्स। एंड इफ वी मेक द ऑब्जेक्ट मूव अवे, if we make the object move away from mirror, the image shift toward focus, and finally when object have infinity, image will be focused. So here in case of convex mirror, image will lie always between pole and focus, not more than that. And this fact is used, we use this fact in using this mirror as a mirror in the vehicles to see the rear view. Outside the body of and inside the car also, to see rear view, we use convex mirror because of this fact. Because if we use plane mirror, in plane mirror distance of image equal to distance of object. In plane mirror, distance of image equal to distance of object. If the object is very far away, we can't see the distant object easily, but object which is close to our eye can be seen easily. In case of convex mirror, wherever the object is placed, image between pole and focus, so that is closer to our eye. So driver can see the object coming from large distance. Second reason is that field of view. This is second reason. Field of view is large. In this region we can see the object. If we use convex mirror, so there are two facts here. Number one, wherever the object is before the convex mirror, image between pole and focus. खूब पूछते हैं क्वेश्चन पेपर में कि why do we use convex mirror as a mirror to see the rear view in vehicles? So first fact is that कि wherever the object is before the convex mirror, image is between pole and focus. Secondly, field of view is very large. Field of view. Now this mirror was also used in the street light system too, because it diverges the beam. लाइट पर तो क्या होता, जो बल्ब होता था उसके ऊपर यहाँ कॉन्वेक्स मिरर रखते हैं, ये ऑब्जेक्ट है यहाँ, तो क्या होता है वो लाइट जो है यहाँ से फैलती है, पूरी स्ट्रीट फैल जाती है लाइट। ओके, नाउ वी विल बी मीटिंग इन नेक्स्ट वीडियो टू डिराइव मिरर इक्वेशन 1/v plus 1/u equal to 1/f and using sign convention and so many things. Thank you.